Is time different in space? A scientific exploration. Time feels constant, a steady flow 1 second after another. But beyond Earth, among the stars, time does not behave the way we expect. Clocks tick differently in space. Moments stretch, slow down, and sometimes nearly stop. So the question is simple, yet profound. Is time different in space? Time as we experience it. On Earth, time feels universal. A second here is a second everywhere, or so it seems. Our daily experience reinforces this illusion. Clocks agree. Aging appears consistent. Cause follows effect in predictable order. For centuries, scientists believed time was absolute, flowing identically throughout the universe. This belief changed forever in the early 20th century. The revolution of relativity. In 1905, Albert Einstein introduced a radical idea. Time is not fixed. According to the theory of special relativity, time depends on motion. The faster an object moves through space, the slower time passes for it, relative to a stationary observer. This effect, known as time dilation, becomes noticeable only at speeds close to the speed of light. For everyday life on Earth, the difference is imperceptible. In space, it becomes measurable. Speed and the flow of time. Imagine two identical clocks. One remains on Earth. The other travels aboard a spacecraft at extreme speed. When the spacecraft returns, its clock shows less time has passed. This is not theory alone. It has been confirmed repeatedly through experiments using atomic clocks on high-speed aircraft and satellites. Astronauts aboard the International Space Station age slightly more slowly than people on Earth. The difference is tiny, just milliseconds, but it is real. Speed alters time. Gravity and time itself. Einstein later expanded his ideas into general relativity, revealing something even more surprising. Gravity also affects time. The stronger the gravitational field, the slower time passes. Near massive objects such as planets, stars, or black holes, time slows dramatically compared to regions with weaker gravity. This phenomenon is called gravitational time dilation. On Earth, clocks at sea level tick slightly slower than clocks on mountaintops. Even modern GPS satellites must correct for this effect. Without these adjustments, navigation systems would fail within minutes. Time is shaped by gravity. Time near black holes. Nowhere is this effect more extreme than near a black hole. As an object approaches a black hole, gravity intensifies beyond anything experienced elsewhere. From an outside observer's perspective, time near the black hole slows almost to a standstill. An astronaut falling toward the event horizon would appear frozen in time, never quite crossing it. Yet, from the astronaut's own perspective, time continues normally. Both views are correct. This is not science fiction. It is a direct consequence of relativity. Is there a true time? If time flows differently depending on speed and gravity, a deeper question emerges. Is there a universal time at all? Modern physics suggests there is not. Each observer carries their own version of time, shaped by motion and environment. There is no single cosmic clock governing the universe. Time is local, relative, flexible. What we know and what we do not. We know time changes with speed and gravity. We can measure it. We can predict it. But deeper mysteries remain. We do not fully understand why time exists or why it flows forward. At the quantum level, time behaves in ways we cannot yet reconcile with gravity. The true nature of time remains one of science's greatest unanswered questions. Time is not the rigid river we once imagined. It bends, stretches, and shifts across the universe. Beyond Earth, seconds lose their certainty. Moments depend on where you are and how you move. Perhaps understanding time is not about controlling it, but about learning our place within it. If you found this exploration meaningful, consider liking this video and subscribing to Interesting Mind Hub. More calm, thoughtful documentaries await, each one inviting you to see reality just a little differently.